Alright, hey there guys. We are back at it with the flipped classroom, and this is section 2 on area of parallelograms, triangles, and rhombuses. So I know yesterday's lesson was pretty straightforward. Probably everything we've done you've seen before. Today may be the same, but we're getting to some more challenging problems. Theorem 11.2 is the area of a parallelogram. And this is based on area of a rectangle. So this formula comes from the area of a rectangle. Thinking back to yesterday, referring base to height, if we refer to this side as our base, to find the height we would have to find the perpendicular distance across from the base. So our height would be this distance here. So we will call the area of a p-gram, and we can abbreviate parallelogram as p-gram just like earlier this year. The area of a p-gram is equal to base times height, which is same as a rectangle. Theorem 11.3, area of a triangle. The area of a triangle is also based on the area of a rectangle. And we kind of have a mini short proof on where this comes from. So if we look at the rectangle over in the corner here, the base and height, let's refer to this as our rectangle. What we can do is draw one diagonal, which would be right here. So we draw one diagonal of the rectangle. This creates two congruent triangles. Based off of side-side-side congruence. If we look at this, they share that dashed side, and then each triangle has a long side, which remember in rectangles, opposite sides are congruent, and they each have the short length. So by side-side-side congruence, or by hypotenuse leg theorem, we have two congruent triangles. The area congruence postulate states that these triangles have the same area. If two shapes are congruent, then they must have equal area, or congruent area. So what this means is that the area of a triangle is equal to 1/2 the area of a rectangle. So we will say area of triangle if we refer back to area of a rectangle is base times height. That means the area of a triangle must be 1/2 times base times height. You may have heard of base times height over 2. Same thing as 1/2 times base times height. Alright, moving on to our examples. We want to find the area of each figure. The figure on the left we'll assume is a parallelogram, and the figure on the right being a triangle. Remember, the area of a parallelogram equals base times height. So in this picture, we can refer to this long side as our base. So our base is equal to 12. 10 plus 2 is 12. We have to find our height. We have to end up finding this dashed line. And if you look at that triangle formed, this is one of our special triangles because we have 60 degrees. This is a right angle. We have a 30, 60, 90 triangle. And if you think back to earlier this semester in a 30, 60, 90 triangle, the short leg, which is 2, this is our short leg, is related to the long leg. To get the long leg from the short leg, remember it's short leg times the square root of 3. So this is 2 square root 3, which is also our height, because it is the perpendicular distance from the base to the other side. So to find the area of this parallelogram, we will take the base, which is 12, times the height, which is 2 square root 3. So altogether, the area is 24 square root of 3. And then we have to put a label on this since we don't know if it's inches or meters or feet. We're going to put units or U squared. So the area of this parallelogram is 24 square root 3 units squared. Looking at the triangle, we're given a base and height, but this one is a little bit different. This time the base ends up being on top because the only perpendicular segment they give us is right here, this dashed line. So this has to be the height. So if that's the height, the base can't be 12. The base has to be what's perpendicular from the height. So the base is 33. So we have a base, we have a height, and I didn't mean to get ahead of myself, but remember the area of a triangle from above is 1/2 times the base times the height. So this is 1/2 times 33 times 11.2. So in the end, if you take out your calculator, the area of this triangle is 184.8, and then we find the label of this is centimeters, so 184.8 centimeters squared is the area of this triangle. So we have one example of parallelogram, one example of triangle. And we will flip over to find our third shape, which is a rhombus. The area of a rhombus is going to be based off the area of a triangle. And we'll develop this area formula on a rhombus just like we did for a triangle in the front. So if we were trying to find the area of a rhombus, we have our picture over here. Remember, a rhombus is a shape that has all 4 sides congruent to each other. So looking at the rhombus, we can draw diagonals. We can draw one through the middle horizontally. And from right here, we know the area of this rhombus is going to be the area of triangle WTC plus the area of triangle WAC. There's 2 triangles we can find the area of, and based off this we know these 2 triangles are congruent because of side, side, side. Because notice they have 2 of the legs are congruent and they have the diagonals congruent here too. So for the next part we're actually going to draw a diagonal going through the middle, vertically through the middle. And if you remember, diagonals of a rhombus are perpendicular. So we have our right angle box. And we will label this point in the middle point E. So the area of triangle WTC, if you remember area of a triangle from last section, is 1/2 base times height. So the area of triangle WTC is 1/2, and the base of this blue triangle is WC. So it's 1/2 of WC times the height, and the height is the distance from T to E. So it's 1/2 of WC times TE. And then finding the area of WAC, which we'll draw this in green. Find the area of this green triangle. Again, is 1/2 times base times height. And looking at this picture, we have our right angle. So our perpendicular distance is A to E, which means our base is WC. So it's 1/2 of WC times the height, which is EA. So 1/2 of WC times EA. And if you look at the GCF, think of our factoring reviews, these two terms have a GCF of 1/2 WC. So if we take out the GCF, which is 1/2 WC, and leave everything else in parentheses, we're left with TE plus EA. So we did a little factoring. From TE to EA, if you look at that red line, TE plus EA is really TA. So we end up with 1/2 of WC times TA. And if you look, WC and TA are both diagonals. So this little mini proof shows that the area of a rhombus is equal to 1/2 times diagonal 1 times diagonal 2. You will not have to know that little mini proof there. You will have to know this, whatever's in the box. You will have to know how to find the area of a rhombus. Right. And then last part, last example. Find the area of the rhombus with side of length 10 inches and one diagonal of length 16 inches. So if we use our picture, we know each side is 10 inches. And they tell us that one diagonal is 16 inches. So if we draw the two diagonals, it's not great drawing, but it'll work out. So we know that this whole distance of this diagonal, we'll call this 16. We want to find the area of this rhombus. Looking back, area of rhombus is diagonal 1 times diagonal 2 times half from this box. So taking that formula, area of rhombus equals 1/2 diagonal 1 times diagonal 2. We know what one diagonal is. We have to find the other. So we got to find our missing information. So we'll scroll down, give ourselves some room. We know diagonal 1 equals 16. Diagonal 2 is that missing piece of information. So how can we find diagonal 2? If we're given one of the sides and we know this long diagonal is 16, we can find our missing piece. If you think back a few chapters, in a rhombus the diagonals are perpendicular and they also bisect each other. So that means this segment is 8, this is 10, we have a right triangle, and we can find our missing piece. We can call that x, and over here this is also x, because diagonals bisect each other in a rhombus. So if we use Pythagorean theorem, we know that 8 squared plus x squared equals 10 squared. 64 plus x squared equals 100. And then from here we can find our x value. X squared is going to equal 36. So we square root that. X equals positive 6. So if x is positive 6, diagonal 2, going back up, diagonal 2 or the second diagonal we do not know, it has one x right here and has a second x because x made up half of that diagonal. So diagonal 2 equals 6 plus 6. So we know diagonal 2 is 12. Using diagonal 1, which we were giving, and then taking diagonal 2, which we found, we know the area of this rhombus is 1/2 times 16 times 12. We end up getting 96 for the area, and the units we use are inches, so it's 96 inches, and area is always squared. So area of the rhombus is 96 inches squared. Some of the problems that we're going to work on in class tomorrow, we'll have to find missing pieces just to find the area, kind of like we did right here.